Hello viewers, in today's session we are going to discuss one important problem from Fourier Sine Transform of functions, right? And here in this lecture we are going to find out the Fourier Sine Transform of this function f of x is equal to e raised to minus ax divided by x, right? So to start with, let us first quickly see the formal definition of Fourier Sine Transform of a function f of x. So the Fourier Sine Transform of a function f of x is denoted by fss, and here we have square root of 2 over pi and integral from 0 to infinity, and we have f of x sine sx dx, right? So this is the Fourier Sine Transform of a function f of x, and here the coefficient we are using is square root of 2 over pi, right? And here the function f of x is e to the power minus ax over x, and we have to find out the Fourier transform of this function using this definition, right? So here we'll use the method of differentiation under the integral sign, and this method is a powerful method to find out the values of important integrals, right? So let us substitute this value of fx in this integral, and then we'll apply the method of differentiation under the integral sign. So now we can write fss, and here we have square root of 2 over pi, and the integral from 0 to infinity f of x is e raised to minus ax over x, and here we have sine sx dx, right? So let us call this integral as integral number 1, right? Okay, now let us denote this expression by the letter I, and here we can see that our integrand is e raised to minus ax over x sine sx, and here we have dx. So let us differentiate this integral with respect to s, right? So what we will get, we have di over ds, and here we have square root of 2 over pi. This is 0 to infinity. We have e raised to minus ax over x, and then we find the derivative of sine sx with respect to s, right? So we have square root of 2 over pi. This is 0 to infinity, e raised to minus ax over x, and the derivative of sine sx with respect to s is cos sx, and then by chain rule the derivative of sx with respect to s is x, right? Because the derivative of s with respect to s is 1. So we have dx, and now this x and this x get cancelled, so we are left with 2 over pi. Then we have 0 to infinity e raised to minus ax over here we have simply cosine of sx and dx, right? So now di over ds is given by this expression. Now here we have this integral, right? So to write the value of this integral, we can make use of a direct result. So now we have a direct result that is 0 to infinity e raised to minus ax, and here we have say cos of bx dx, and the value of this integral is a over a square plus b square, right? So comparing this integral with this one, here we have sx, so b can be replaced by s, right? So now we have di over ds is equal to square root of 2 over pi, and here we have a over a square plus b square. So a is a here, and here we have a square plus b square, and b can be replaced by s, so we have s square, right? So now we have a differential equation that is di over ds is equal to square root of 2 over pi, and here we have a, and here we have a square plus s square. So now our aim is to solve this differential equation with some boundary conditions, right? So what we will do, we'll integrate both sides with respect to x. So integrating both sides with respect to this variable s, we have di, and here we have 2 over pi a, and here we have ds over a square plus s square. So now integrating both sides, here we have c as the constant of integration. So here we have I, this is a square root of 2 over pi a, and the integral ds over a square plus s square, and c is the constant of integration, right? Now here we have a standard result. We know that the integral say dx over a square plus x square is given by 1 over a tan inverse x over a. So now utilizing this result over here, we have I is equal to square root of 2 over pi a, and the value of this integral is 1 over a tan inverse s over a plus c, right? Now this a and this a get cancelled, so we have I is equal to square root of 2 over pi tan inverse s over a plus c, right? So this is the value of the integral I, which is also the Fourier sine transform of this function e raised to minus ax over x, right? Now our aim is to find out the value of this constant of integration. So to get the value of this constant of integration, let us substitute in equation 1 s is equal to 0, right? So when s is equal to 0, then sine sx is equal to 0, because we have sine 0. Right? And when this value is equal to 0, then this entire expression is equal to 0. So we have I is equal to 0, right? So the conditions are when s is equal to 0, I is equal to 0. So let us utilize these initial conditions in this equation. So here we have 0, and here we have square root of 2 over pi tan inverse 0 over a plus c, right? And this is the tan inverse of 0, that is equal to 0, right? So this value is 0, so we have 0 is equal to square root of 2 over pi times 0 plus c, so c is equal to 0. Right? So the constant of integration c has the value 0. So I is now equal to square root of 2 over pi, and here we have tan inverse s over a, right? So this is the Fourier sine transform of e raised to minus ax over x, because our integral I is equal to the Fourier sine transform of f of x. So we have fs of s is the Fourier sine transform of this function f of x. So now let us consider one more problem in which we have to find the Fourier sine transform of a given function, right? And here the function is f of x is equal to 1 over x, right? So utilizing this definition of Fourier sine transform, we can now write the Fourier sine transform of this function as fss, and here we have square root of 2 over pi and 0 to infinity. For f of x we can now write 1 over x, and here we have sine sx dx, right? So let us call this integral as I, right? So now our aim is to find out the value of this integral, and here we'll try to reduce this integral into the famous integral of Dirichlet, right? So we'll reduce this integral to a Dirichlet integral by making the substitution. Let us take t is equal to s times x, right? So here I will make this substitution. So we have t is equal to s times x, so dt over dx is equal to simply s, because the derivative of x with respect to x is 1. So now we have dt is equal to dt over s is equal to dx. So now let us change the limits. So here when x is 0, here we have x, then the value of t is s times 0, that is equal to 0. And when x tends to infinity, then here t also tends to infinity, because when we take x tends to infinity in this expression, then t also tends to infinity. So now I can be written in terms of t as square root of 2 over pi, and here we have 0 to infinity, and 1 over x. X is it can be written as t over s. So here we have t over s, and here we have sine of t, because s times x is equal to t. And for dx we can now write dt over s. So let us rearrange the terms here. We have square root of 2 over pi and 0 to infinity. Here we can now write this term as s over t, and here we have sine of t, and here we have dt over s. So this s and this s get cancelled, and we have square root of 2 over pi and 0 to infinity and sine t over t dt, right? So now this integral is known as Dirichlet integral, and we can find out the value of this integral by different methods, namely Laplace transform, and by using other methods, right? From complex analysis also we can find out the value of this integral. So the direct value of this integral is here we can write pi over 2. So 0 to infinity sine t over t dt is equal to pi over 2. So I is now equal to square root of 2 over pi times pi over 2. So we can now write square root 2 over pi, and taking pi by 2 inside the square root sign, we can write pi square over 4. So this is square root of here pi and pi get cancelled, and here we have 2. So this is square root of pi over 2. Right? So the Fourier sine transform of this function f of x is equal to 1 over x is given by square root of pi over 2. So now let us consider one more important problem from Fourier sine transform of functions. So here we have to find out the Fourier sine transform of f of x, which is equal to e raised to minus ax, right? So what we will do, will make use of this definition and will substitute f of x as e raised to minus ax over here, right? So the Fourier sine transform of this function is given by square root of 2 over pi. Then we have 0 to infinity, and f of x is e raised to minus ax and sine sx dx, right? So to get the Fourier sine transform of this function, now we have to evaluate this integral, right? So to get the value of this integral, we'll make use of a standard result, and the result goes like this. The integral 0 to infinity e raised to minus ax sine bx dx is given by b over a square plus b square, right? So if we compare this integrand with this one, then here we have a and here we have b. So we can replace b by s, right? So for for b we can now write s. So the value of this integral can now be written as b over a square plus b square. B is s, and we have a square plus s square, right? So here's the Fourier sine transform of the function e raised to minus ax is given by this expression, that is square root of 2 over pi s over a square plus s square.